Let's do this example problem. We're given the following information about the circuit, and we're going to find omega, the angular frequency, the impedance of the circuit, I maximum, and the phase angle. That's the angle in our phasor diagram between the potential and the current. The first one is pretty straightforward. We know that the sine of omega t is the formula, so omega must be 100 radians per second. For part B, let's take a look at our formula for impedance. The resistance is given. We need to figure out what the reactance of the inductor and the reactance of the capacitor are. "16 ohms for the inductive reactance, and 101 ohms for the capacitive reactance." So Z, our impedance, turns out to be 109 ohms. Now we want to find I maximum. We know V is IR, or V is the impedance times the current. So we can solve for this, and this is given the maximum voltage. The maximum voltage is given, that's the amplitude of the function, 40 volts. And so we have the maximum current. Now we want to find our phase angle. If we look at our phasor diagram and we plot the maximum voltage across the resistor and the maximum voltage across the inductor and the maximum voltage across the capacitor, we actually see that the capacitor has a larger maximum voltage than the inductor. And let's go ahead and calculate those now. Those are the values I get, and we can see when we do the calculation, the voltage across the capacitor is larger. The maximum voltage across the capacitor is larger than the maximum voltage across the inductor. So our phasor diagram actually is going to have this look to it. And of course, what we're interested in is this angle right here. We already know the length of this red vector. What does the length of that red vector have to be? V maximum. And we know V maximum is 40 volts. So a good check right now would be to see if you get 40 for this. 24.96 squared plus 31.2 squared, square root, should give you V maximum, should be 40 volts. I checked it and it's pretty close. So let's find our phase angle. Inverse tangent of 31.2 over 24.96, and I got 51.3 degrees. Now we're below the horizontal. Because we are below the horizontal axis, that means this angle should be negative because we go in the counterclockwise direction to measure our angle, our positive angle. And there we have it.